Alright, so welcome to the 11th video. This problem is going to be about data analysis. We'll be given a graph and we'll be asked to analyze it and answer questions about it. So the question says the following. First, it says the graph below shows how the mass of copper deposited during electrolysis varies with time. It is the mass varying with time. Just by visually looking at the graph, we are able to identify that there is a linear relationship between the data points and that linear relationship is positive. So that as a first glance, but the actual questions are first identifying the dependent, independent, and controlled variables. Second, stating the relationship between independent and dependent variables. Third, calculating the rate in grams per minute of copper deposition to 2 decimal places. And finally, stating two useful mathematical operations that could be performed in the graph. So without further ado, let's look at part A. Now, it asks us to identify the dependent, independent, and control variables. Taking into account that we have a graph that we can take advantage of, identifying the dependent and the independent variable is fairly easy. The dependent variable is displayed on the y-axis of a graph, and the independent variable is displayed on the x-axis of a graph. So we basically just need to look at the image that is provided to us and see that the y-axis is displaying mass of copper deposition. The y-axis displays the dependent variable, so our dependent variable is mass of copper. Same thing goes for the independent variable. The independent variable is displayed in the x-axis. The x-axis is displaying time, so our independent variable is time. Now, a control variable is present in the image as well. It is right here. It says that the current is 4 amperes always. It does not vary with time or with the amount of copper that is deposited. The current is always 4 amperes in all cases, so that variable is the one that is controlled. So our control variable is current. You state that the dependent variable is mass of copper, the independent variable is time, and that the control variable is current, and you'll obtain the 3 points. Now, that is part A. Part B asks us to state the relationship between the independent and the dependent variables. When I was presenting the problem, I gave the graph a first glance, and I said that one was able to identify that the data points had a positive linear relationship. Now, whenever there is a positive linear relationship between the data points, that means that the dependent variable and the independent variable are directly proportional to each other. So, by looking at the graph and identifying the positive linear relationship, we are able to note that mass of copper deposition is directly proportional to time. So when you state that our dependent variable is directly proportional to our independent variable, which adapted to this scenario of the exercise is the mass of copper deposited is directly proportional to time. So that would be part B. Part C asks us to calculate the rate in grams per minute of copper deposition to 2 decimal places. Now, for this, we must note that the rate of copper deposition will be the mass deposited divided by the time it took. So we need to look at the graph and select one of the 4 points that is given to us and divide the y by the x value of that coordinate. So I selected this point right here because it was the one that gave the most accurate and the most precise value for the x and y coordinates. So here in this point, we know that the time is 15 minutes and that the mass deposited is a little bit less than 1.25 grams, so 1.24. Now we need to divide that y value, so that 1.24, that mass deposited, by the time it took. So that y, 1.24, divided by the x value of the coordinate, which in this case is 15 minutes. You divide 1.24 by 15, you get that the rate is 0.08 grams per minute. If you follow this same procedure with any of the points in the line, you should get the same answer, as the rate is not changing. Now that would be part C. And part D, which is the last one, asks us to state 2 useful mathematical operations that could be performed on the graph. Now there are really 3 possibilities. Interpolation, which is figuring out one data point within the line and the values that are given. Extrapolation, which would mean extending the line and figuring out values that would match the relationship but that are outside of the range of values that is given. And the area under the curve. If you mention any 2 of those 3, you would get the point, either interpolation, extrapolation, or area under the curve. 2 of those 3, and that exercise would be marked as correct. So that would be the end of this problem. I hope you learn a little bit more about graphs and how to use them to your advantage. And again, the link to the presentation is in the description if you find that useful, and thank you.